Hello, I'm Christian O'Mara, and today we are going to be talking about the greatest common factor and the least common multiple of two whole numbers that are equal to and below 100. So to get started, we're going to start off with greatest common factors, also known as greatest common divisor, and that is the largest factor of two numbers, or sometimes even more than two numbers. And you might ask what a factor is. It's a number that can be multiplied together to make another number. So for example here, we got 6. Its factors are 1, 2, 3, and 6. That's because 1 times 6 is 6, 2 times 3 is 6, so on. Then 10s, it is 1, 2, 5, and 10, and then 7 is 1 and 7, just because it's a prime number. So let's get started with greatest common factor. So we're gonna choose two whole numbers. So let's just say 50. Let me rewrite that. So 50 and also 70. So 50 and 70. So what we first want to do is we want to find the prime factorization of both these numbers, and we are going to do that by factor trees. So start with 50. 50 can also be written as 10 times 5. And then 5 is a prime number, so we are going to circle it. And then 10 can be written as 5 and 2. 5 times 2. And both these are prime numbers, so we're going to circle those. And then for 70, we're going to write that as 7 and 10. 7 is a prime number. Then 10 as 5 and 2. And these are both prime numbers. So sometimes, for me, it helps to write these out, like just down here. To say that equals to 5, 2, and 5 again. And then for 70, that's equal to 7, 5, and 2. So now what we want to do is we want to find pairs in these. So we can say that there is a pair of 5s right here. And there's also a pair of 2s. Right here. So the 7 and 70, that can be marked out because there's no matching 7 in the 50 prime factorization. And we can mark out the 5 because there's no other matching 5 in the 70 prime factorization. So we see that we have a pair of 5s and a pair of 2s. So now all you have to do for this is multiply them together. And that equals the greatest common factor, which is 10. So that's the greatest common factor of 50 and 70. So moving on, we're going to talk about the least common multiple, and that is the smallest multiple of two numbers, sometimes more than two numbers. And a multiple is the result of multiplying a number by an integer. So for 6, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, so on. And I also have it written for 10 and 7. So 10, 20, 30, 40, and 7 is 7, 14, 21, and 28. Those are multiples. So to get started with the least common multiple, we are going to do the same thing. Well, start the same way as we did in the greatest common factor, which is do prime factorization and make a factor tree. So let's do two different numbers this time. We are going to do, let's do 6, and let's also do 10. 6 and 10. So to start off, I'm going to write these a bit further this way, censor them a bit more. So 6 and 10. So 6 can be factored down to 3 and 2. Circle them because they're both prime. And then the 10 is 5 and 2. Circle them. So it helps to write these out at the bottom. That's 3 and 2. And then 10 is equal to 5 and 2. So what you want to do is you want to look at each of these factors individually. So starting with 3. So starting with 3 right here. We want to see which has more 3s. The prime factorization of 10 and the prime factorization of 6. So we can see that there is no 3s in the prime factorization of 10. So we're going to circle the 3, which I already did, and then move on to the next. So 2. So we see there's a 2 in both the prime factorizations of both 6 and 10. So for this, you can circle any of them you want. So just circle 2, and then you're going to mark out the other 2. And then moving on to 10's prime factorization. There's a 5 left. There's no 5s in the 6 prime factorization, so you're going to circle this. And then what you want to do is you're going to multiply all the circled numbers. So 5 times 3 times 2. And that is equal to 30, which is the least common multiple of 6 and 10. And then since this was a pretty straightforward example, I'm going to do another example with a bit larger numbers. So let's say 24 and also 40. 24 and 40. So we're going to do the prime factorization using a factor tree. So we're going to say this is 6 and 4. 6 can be written as 3 and 2. Both prime numbers. And then the 4 can be factored down to 2 and 2. Now for 40, 4 and 10. 4 can be factored to 2 and 2. The 10, 5, and 2. Those are both prime. Okay, so now that we got this, we're going to write out the factors. The prime factorization of both of these. So that's 3, 2, 2, 2. And then 40 is 2, 2, 5, and 2. So we're going to take the first factor, which is 3, and we want to see which prime factorization has the most 3's in it. So 40's prime factorization has 0, 24 has 1, and then 24 has 3 2's. 40 also has 3 2's, so you can choose whichever one you want because it's the same value. So I'm just going to circle these and then mark the other ones out. And then 40's prime factorization has a 5 in it. There's no 5's in 24. So we're going to circle that and multiply all these numbers together. So 2 times 2 times 2 times 3 times 5. So this right here is 8. This right here is 15. Then 15 times 8. 15 times 8 is equal to 120, which is the least common multiple of both these numbers.